All right, hello Advanced Lab class. This is a really quick video about something that's going to be important going forward as you take data in this class. And over here, I have an image of, let's say this is like a block that you're measuring the length of, right? So the idea here, as we introduced before, is that if you have any function, a function f, which is maybe a function of two variables x and y, I'm not going to write down a function, just something random. Uh, that function f has an uncertainty delta f, which depends on the uncertainties of the individual measurements x and y. So if you recall, this is the partial derivative of f with respect to x times the uncertainty in x squared plus the partial derivative of f with respect to y in this case times the uncertainty in y also squared. And so what's going to be happening often in these labs is you'll have something you're interested in f, but you're actually taking measurements of x and y. So here, x and y are measurements and they each have uncertainties, delta x and delta y. They each have their own individual uncertainties. So what that means is that anytime you measure anything in this class, it's going to have an uncertainty associated with it. So let's talk about the rules for that. So on the top here, I have a ruler and I have this block. Let's say one of the labs, you have to measure the length of something. I don't think there's actually anything too rudimentary in this class, but that's something that could happen. And so if you have this block here, you would just count on this ruler. You measure with a ruler how long something is, right? So if these are ticks of, let's say millimeters, so this is 5, 10, 15, 20, 25, 30, 35, 36, looks like 37. So this length here is 37 millimeters. So then you might ask, okay, what's the uncertainty on that? So there's all sorts of different conventions for this, and you might have heard them differently in the past. My rule of thumb in general is that for any measurement, I'll even write it over here on the right, that just says for instrument uncertainty, and that's what we're talking about here, ruler is an instrument. So the question is, what is the instrument uncertainty? So delta L equals what in this case? So what you want to use in general is use the least count on the equipment that you're using. So in this case, what that means is that the least count on a ruler is 1 millimeter. So you would just say 1 millimeter. So this is 37 plus or minus 1 millimeters is the length of this object. Now you might say, Professor, it's clearly better, like I know it closer to 37 than 38 or 36, and that may be true sometimes. But usually your instrument should be good enough that you have these ticks close enough that you just kind of err on the smallest measurement that you have, like the resolution basically. There are cases where you might need to guess it, like if you had like large gaps in this. Let's say this only had gaps every 5. In that case, you kind of have to guess what the 5th one is. And that might change. It might be more than 1 millimeter or less. But honestly, for this class, the easiest thing to do is just use the least count of the equipment. In general, you almost always underestimate your uncertainty. When you do this lab, you're going to get values for fundamental constants that you know about. And what you're going to find out is you're going to get a value with actually kind of a small uncertainty, and then it's not going to be close to the actual value. So that shows that you're underestimating uncertainty. We almost always underestimate uncertainties in these classes, other stuff going on. So the simplest rule is just use the least count of the equipment. The one thing that's like a caveat of this is that this class has a lot of digital readouts. So if you have a digital readout, let's say you're reading a voltmeter, right? And it's reading millivolts, and it's telling you that you have 10.2678 millivolts, and it's reading that. You might say, okay, great. That means the least count is this digit here, right? And that may be true, but that may not be true. So for a digital readout, what you want to use is use the digit, or the, what's it called? Use the, sorry, I want to erase erase this. Use kind of the last, or the first or last, depending on which way you're going. Use the first stable digit. What do I mean by that? Is that often you'll plug in this, especially if you're reading millivolts, and the numbers will be fluctuating a lot. So the 10, the 1 and the 0, and maybe the 0.2 and the 6 would be stable, but the 7 and 8s are kind of like bopping all around. And so what that means is that you wouldn't use the 8, let's say in this case, you would actually use the 6, right? So if the 7 and 8 are fluctuating a bunch, that means you would write down 10.27, you'd round it, millivolts in that case. So this is going to be really, oh, you can't see it, it's over my face, but 10.27, here I'll write it up this way, 10.27 millivolts. Because the 7 and 8 are fluctuating too much. So this is going to be really experiment dependent. Some of the experiments, like the superconducting experiment, it has a lot of digits, especially past the decimal point, like less than a millivolt, but they fluctuate quite a bit. Or you might have some, like in the double slit experiment, if you hook up in the first part of the class, first part of the experiment with the photodiode, that value is actually extremely stable. And then you would just use the last digit. So for a digital readout, you kind of have to look at seeing where it's fluctuating to see where to do it. So in general, for instruments, just use the least count. That would be the uncertainty for the experiment, 1 millimeter for a ruler, might be 0.1 volts for a certain type of multimeter, etc. Or if it has a lot of digital digits that are fluctuating, do those. If there's a case where one of these two rules doesn't apply, ask me, ask the TA, and we'll kind of work you with it from there. But the idea is that every measurement you have has to have an uncertainty. I'll write it over here. Every measurement has an uncertainty. If you give me any kind of paper or notebook or anything that has values with no uncertainties, that'll be marked as incorrect. So I hope this was helpful, and hope you guys have a good time starting the experiments.